Time appropriate greetings for whenever this video finds you. We are live once again on our mini series exploring the RHEL 10 beta. I'm your host, Matt. In the booth is producer Scott, and joining us once again, our special guest all the way from the terminal, Nate Laker. How are you today, Nate?
They let me out of the terminal for
That's
a
good.
change.
That's good to you. The fact you can find your way out on occasion is a good thing.
Yeah, I mean, sometimes you really just need to get your eyes to refocus on the real world and get some air. You know, it's important.
Yeah. The games aren't nearly as fun as one would expect. So we are back again this week. Last week, we had a special guest from the Fedora Ambassador Group. Week before that, Nate and I, maybe a little too ambitiously, decided we were going to do a live coding feature deep dive on the new pod support in quadlets. That is our release note of the week. Again, this is letting us try to jump straight into config files for pod support for quadlets. We're going to talk a little bit more about what that means. Maybe 15 minutes was a little too ambitious. We got close. We'll go over where we are. I have done zero prep work on purpose. We're this beta virtual machine is exactly where it was when we left off. But Nate, why don't you go ahead and get us back to just what was the premise? Like, what did we start with that we had this conversation originally?
So I guess really to summarize, I threw Matt's brain into a loop when I said that I put all of my containers in pods, even when there's only one container to deal with. And then we talked about why. And then, well, Matt decided to try to do that with an application that he wants to try to run. And then we went down the whole rabbit hole. Let's build a pod. Let's put the container in the pod. Let's export that to a YAML file. And then where it went kind of off the rails was how we got it defined with systemd. And I shouldn't say off the rails. We ran into some issues and then ran out of time.
Yes, exactly. And yeah, so I am getting on the pod train for all things. I'm still not sure if I'm there yet, but I'm definitely on the quadlet train. That you and I totally agree with.
Yeah.
There's one question from the comments from last week, and please forgive me as I will mispronounce your username. But from El Abadabi, we have a question about something we did during that video, right? So as you just described, the way that your current workflow is, you create a cube.yaml from a pod definition and then turn that into a systemd service. And we probably weren't clear, maybe across the board, on how quadlets become systemd services. So if you could go into answering that question for El Abadabi and the rest of our audience. Let's
Sure. So, I mean, the simple answer is there's a way to point quadlet at your YAML definition, and then it'll treat that whole pod as a service, right? I do have a Git repository that I have put an example in that I use to share, like, whenever someone asks me how this works. It's a common application, WordPress. I run a lot of WordPress this way. This is pretty much exactly the way that I lay this out. But you have your YAML definition, which is the pod itself. And I'm sorry if this is hard to read. If I make it any bigger, then the screen starts to get too cluttered. But this is what we showed last time, right? This is what that YAML definition looks like of a pod, right? It's got the pod name. And of course, you would change that if you were going to try to deploy this to whatever it is you want to call that pod. And then it's got the containers defined and the persistent volumes and things like that. Now, the real question was, okay, how do I turn that into a systemd service? And that is through quadlet. And there's a subdirectory here called quadlet inside of this repository. And a few seconds ago, this repository was up on the screen. And I guess I'll give it to you, Matt. We can include it in the description of the show. And there it is back on the screen. So if you want to go look at it, this should be a public repo people can look at. So this is actually really simple. There's a WordPress-pod.cube. Now, the name doesn't matter. The .cube extension is what matters. This is what tells Quadlet what I'm going to point you at is a cube YAML definition, right? And then it's really simple. It's a couple lines. It's, what target wants this. This is basic systemd stuff. And then in the cube section here, we say, where's the YAML? And we point to the directory that the YAML is in. In this example, I just put it inside of Etsy containers systemd WordPress-pod.yaml. It doesn't have to go there, but it's convenient to put it there because paths are easier then. And in this case, I use a config map, which is something else we talked about in the last episode. So you have to tell Quadlet where the config map is as well. If you're not using a config map, you just ignore this line. And then you also have to tell it what ports it's supposed to open, because when it defines this, it's basically building your pod out. And when it builds out the pod, it has to know what ports to build into the pod. Now that's also defined in the cube YAML. So I'd have to really dig deeper into why you also have to define it in systemd. Maybe it's a systemd thing where it has to tell it what ports are allowed. I'm not really sure. But
Sure.
So that should answer the question. You would then take this, put it inside of etc container systemd, do a systemctl daemon reload, and then you should have, in this case, a service called WordPress-pod that you can start, stop, restart, whatever. And it acts the way that we described it in the last episode.
Right. Yeah, I think that might have been something we glossed over in the last episode, is that quadlet, right, which we'll get back to the sort of dry run command we ran last time so we can see where we were. But quadlet is actually an auto-generating systemd tool, right? So these things, simply by the fact that we have put the correct files with the correct relationships between the files in the right directory, we have a magic systemd service. Like, we don't actually have to do anything else, because quadlet and systemd together take care of turning that into an auto-generated transient service in the appropriate systemd parlance.
We did show in the last episode how to ask Quadlet to show you what it's going to generate. There's that dry run command that we used and what that does is it reads in all these definitions that we put inside of etc container systemd, and it spits out what the service files are going to look like.
Correct.
So it's good for troubleshooting.
Exactly. And the other thing to point out, since you still have it up on the screen, which I think we're going to actually wind up getting into later, is that so it's not by coincidence that these quadlet files are using the systemd syntax. That is the entire purpose. We also see things like, unit and install, which are directly the systemd unit file definitions, which allow us to do things that we wouldn't normally do, like that install right there that you have. That actually allows you to do things like enable and disable services, which are typically not something you do with an auto-generated service, right? So if you didn't have that install, it's not necessary. It will auto-create one, but it also means you can't enable and disable the service without removing the quadlet. So
this also lets you define sort of the order of operations, right? This service, if it depends on network storage, for example, in my home lab, I use a Synology NAS to store a bunch of the volumes, right? If NFS or networking isn't up before my pod starts, the pod can't start because it can't reach the volume, right? So you can set dependencies in here in the same way that you would for systemd unit files.
Exactly. So hopefully that answers the question we answered that was asked from the last episode. We do have also some comments on the episode itself, so hopefully we got that out there. Let's go ahead and dig into where we left off when we ended. So this is the Red Hat 10 beta system we were working on. So I want to go back and sort of level set where we were, how far we got. I will use that quadlet dry run because I think we had a good idea of what the likely issue was. So, like Nate said, right, the .cube file, that's what is the special file that tells Quadlet, aha, not only am I starting, a general Quadlet, but also that it is a Kubernetes YAML that I am looking at, and that's what I need to go find. We also have a special .pod file. That's the new thing that we are looking at this time. So Forgeo is the application of choice that we're building here. Forgeo, for those who don't know, is a open source GitForge. Think SourceForge, think GitHub, think GitLab. It's along those lines. So the pod file, right? So this is another one of these systemd formatted unit files that we're creating especially here. Right now, all we're doing is exposing the port, and we're creating a name.
Now, just to avoid confusion,
Yes.
Matt is taking a different approach to defining the pod than I do in that Git
Correct.
repository that I shared earlier. He's trying to use there's a way to define a pod in systemd, and that's what you're trying to do here, right?
Yes, brand new with Podman 5. So that's why we're doing
Right.
this in the beta context, because you need at least Podman 5 in order to be able to do this. So whereas in a standard non-podded quadlet, we would have a container file. We have that here as well, right? So we have the container that defines our Forgeo part of our app, right? And this is some basic stuff. We've got, some environment variables we're passing for user ID. We've got the image we want to use. We are using a network. You can see we've got a .network. We'll get into that in a second as well. We are also publishing the ports here. I don't think we need to do that on both the container and the pod, so I might delete those just to see what happens. And this is how we are now telling it that it is part of this pod, right? Instead of going through the route that we did before. So instead of putting it in the YAML, this is where we sort of build that cohesive structure that is our pod linkages between all these files. All right. So let's take a look at our network first. This is mostly because I am directly taking this from the definitions on the Forgeo install docs. We're very nice enough to have a working pod definition and a Docker Compose.
That is nice of them. A lot of projects don't. They just go right for Docker Compose, and if you're trying to build a Podman infrastructure out of it, you either have to translate that yourself or use Docker Compose with the API that it can stand up.
Exactly. So this is our network definition, right? So this is right for quadlets. .network is how you define those. We're not doing anything particularly special here. We're just naming it, which means it's not going to get a special set of IP addresses. But if you wanted to do all that, you've got all your full control over a Podman network that you normally would have. You can define those things here. Like in the other examples, exposing things to the host, however, that is where you would do that in the pod definition, not in the network stack. The other thing we have here is a volume, Forgeo.data volume, right? And again, we're not doing anything in particularly special, which is what we tripped over, I believe, at the end of our last episode. So this is just we're creating a Podman volume, auto-managed and auto-created by Podman, so it's going to live in the Podman structure. And I think we're gonna do two things today, because I think this is where we went wrong with our next container. But as you mentioned, probably for something like Forgeo, where we're trying to get MySQL up and running, you probably do want to have some sort of more permanent and more correct file system path, either that has external storage or somewhere else mounted. So not necessarily using the Podman auto volume function.
Now, I feel like you could, and that would be safe. The downside would be where it's getting placed on your file system isn't as predictable.
Exactly.
I'm sure you could get it. You could ask Podman, tell me where my volume is, and then go get it. So in a case of like a production deployment where you need to know where that data is so you can do stuff like back it up.
Exactly.
Right. Or if you want to direct where it goes, like in the case of me and my NFS volumes, right, then it gets to be a little more tricky.
Right.
That's all.
Yeah. Now, if you're passing in like a complete device, like from a SAN, you can actually do that via Podman. Yeah. You can pass it a whole device. But if we've got, file shares if we got network devices that are mounted to locations, this is where I'm going to move. We're going to try to do this both ways. We're going to troubleshoot with the auto volume and this is our culprit, right? This is the thing we are trying to add, and we've been trying to add this by taking from the Docker Compose and making things work, right? So this is our MySQL container. We're adding a database backend to this. So this is what forms our 2-container pod. This is that definition, right? This is how we identify that it's all part of that pod. And this is where we went, I believe, wrong last week, right? Here we're using the sort of standard pass in a path, but there's no there. So
Yeah. I think that just needs to point to a proper local file system.
exactly. So rather than do that first, though, just to troubleshoot, I want to go ahead and actually, you know what? Before we do that, let me go ahead and whoops.
Yeah, it's like quadlet. Oh yeah, Podman, quadlet. There you go. Dry run.
Because options are always different. This has no.
Might be dry dash run. I'm not sure.
It's not. That's what.
There you go.
That's what I feel like it always should be, but for whatever reason, within the container, it's always one word. So this is the dry run command. So this is right. It's a user libexec, which means it's really something that's called by the system. It's what systemd uses on the back end to actually make the real service files. This is how you can see what systemd is going to do when it tries to generate these things, right? And we can get things like we didn't create any requires and any sort of dependencies here, but we can see that the pod is going to actually do all of this for us, so that the pod starts before our containers start, and then there's other things in here.
That is so that's a benefit here there's a benefit over the quadlet or the quadlet with cube that I do, because when you bring up the cube YAML, when you define the pod that way, there's not a dependency structure in that YAML file.
Right.
It assumes that the containers are smart enough to know when their dependent services are functioning and do the appropriate things to restart themselves or whatever. So that's a thing I run into a lot, where I have certain services where if the containers just happen to come up in the wrong order, the service doesn't work right. I have to restart the pod or restart an exact service within the pod, which is unfortunate.
Yeah, exactly. It also gives us hints if we do run into an issue, like,
right,
MySQL has to be up before the Forgeo app can be. Like we have some hints now to be like, oh, if we set up a unit file, right? And this helpfully tells us each service that is right. These are much larger and much longer than what we created. But it does things like, here is where we have all of our mounts and what it's looking for. And this is clearly, I think, where we ran into problems, right? Is it's looking for these things that don't exist. So what we're going to do is we're just going to go ahead and we're going to copy that Forgeo data volume to MySQL data volume. We're going to let it auto create.
There you go.
Something for us, and then so I don't fat finger it in a second. We're going to go ahead and we're going to do that twice. So now we've told it, really, we're going to use this Podman volume called MySQL data, and I want you to mount that at varlib MySQL. So, and I've been doing this all locally, which means I need to copy our changes into our correct path that we were talking about, right? And this is how we are essentially creating the quadlet definition. And I am blindly copying over whatever was there, because earlier today, the only setup I did was to copy these files out to the local directory and then copy them back. And now we are going to blindly trust that we did the right thing, Nate. Because that's how we do systemctl. Daemon reload. If I can type today, this will go much faster.
Systemctl is a tough command to type. I'm just telling you.
It is. And Daemon reload has weird letters in weird places.
Yeah.
And I forgot the T even after you said CTL.
I told you, it's hard. It's hard to type. Hard to type.
All right.
Service was so much easier to type.
It kind of was. Start. So now we should have the ability to start our 4JO pod, and that should start all of our things. Well, it didn't fail this time, so that's a good sign.
That is a good start.
Pull up some status. Active running. Pod create. All right, so we have our pod. We have our infrastructure pod. We talked about that last time. That's the very first thing that Podman creates in order to get the namespace up and running while it does other stuff. Right? We already have our images pulled locally, but if we didn't, like, it would download those things, and during first configuration, like, it has to have something there so like it can create all the networking and everything around it. So we have that infrastructure pod that sort of is a placeholder. It's doing some things. It's doing container starts. We have things up and running. Cool. So this looks like it might be a real pod, mate. So Podman.
You did a pod PS. We should see it.
Pod PS, right? That's correct. That's what you told me to do. That is showing me last week's
that doesn't look good.
Pod. So that is not actually showing up that way, which is interesting.
Oh, I know why.
Why is that?
Do it with sudo.
That would be a very good pickup, right? Because we're looking at system services, not my personal user services. We now have our 4JO pod. It is up and running. And we can do something like this. I think I need to throw the...
So, folks, while Matt is struggling to get the right command typed, just going to remind you all, if you like this kind of content, make sure you subscribe to the channel. We do stuff like this pretty frequently. In fact, every Friday, as Matt was alluding to at the beginning of the show, Scott and I drop into the terminal and we give you all kinds of examples of real-world Linux skills. So that's something you can look forward to every week. And Matt's been doing this series too, so we won't try to.
Yeah, and definitely hit the bell because we are nearing the end of our mini series, but we're also dealing with some scheduling issues. So we have a hiatus coming up again, but we were looking to come back for at least one more episode. So yeah, notifies, subscribe.
To be determined, things. Right?
To be determined
is the point. So if you don't hit the bell, you won't know it's coming.
It's the only way to find out. All right, so it looks like
so what do you got?
Pod logs. It looks like we got all the things, right? We have our database is coming up. It's doing the initialization. It says, hey, I have a database. I have a directory. It didn't fail this time, which is what happened last time. So it looks like our troubleshooting, let Podman worry about it. That actually worked. And right there, ready for connections. Cool. We set the passwords. We did all those things. We got the database set up, and I think we look like we're all good here. So,
cool. Did the Podman Pod PS show that all the proper containers were running? I missed that while I was busy shilling for the like and subscribes.
Let me go back there, and you can tell me. We've got 2 containers, so that should be correct.
Yeah, well, it would say degraded if it wasn't running properly.
Exactly. So the one thing we can do here is go to our browser, and I need to remember. Actually, you know what? I don't need to remember. What I do need to remember is I think we exposed port 3000. So,
what port was it on? We did all this work, and it's been weeks.
And Firefox does not like so I've got libnss involved here. So I need to actually probably grab the actual IP address. The other thing I should do, right, Nate, since we're exposing a port, is actually make sure it is exposed. And it does appear to be exposed. So I think that is
You don't have a firewall D that might be not allowing it?
No, we'll find out in a second. If we can't get to it by IP, that is the next place I will have to check. All right, so there we are. It is most likely a firewall issue. So let's go ahead and open that, right? Because, well,
just firewall-cmd.
Let's do this first.
There you go.
Apparently, I can't type anything today. Not systemctl, not localhost.
Typing's hard.
Uh-huh. Well.
Connect the server.
Sometimes, yeah, we appear to have a different issue.
So do a Podman PS-A. And it should show you what the definitions have here. Yeah, it's got 222 directed to 22 and 3000 directed to 3000. So, oh, you don't, the Forgeo container is not running.
Mm-hmm. The Forgeo
MySQL container is running. There
That
you
is
go.
an interesting.
That's why it's not working.
Right. We should have had 3 containers, right, Nate? We should have MySQL.
I thought that looked off because it should have had the infrastructure container as well. But then I thought, well, we did it with Quadlet. Does it treat it differently? But here we can see, or the actual application is not running.
It does not. So our issue is the Forgeo service. So because these are individual services as well, right, we should be able to go ahead and say systemctl status. All right, so this gets us that specifically for the MySQL service portion of our pod, which is it's a case for naming things correctly. I'll just leave it at that. We can talk about that later. Now, we should also then be able to say there is a Forgeo service now, because that is the name of the container that is in our Forgeo pod service. And we do indeed have a problem with our Forgeo definition. So let's go ahead and
if you should be able to get journal control logs out of it if you did a journal control XEU on Forgeo.service. And that might give us a hint as to what went wrong.
all right. What do we have?
Failed to start.
Not really a whole lot. Just failed to start. Repeated too quickly.
If you scroll up a little bit, does it give us any more? Or is there nothing above us?
Well. Cannot listen to TCP port address already in use. I think that answers our other question.
So, yeah, that's because the pod is already listening on that port.
Exactly.
So the container should not listen on the port. So
I was curious what would happen.
There you go.
What happens is it fails.
Yeah. And I should have known that.
Well, I thought about it and I was like, you know what? It's better to watch it fail because that's what we're here to do, Nate. We're here to learn.
We're here to make things fall apart.
Exactly. And we'll make sure that folks at the end know the right way to do things.
And the right way to not do things.
We eliminate, which we should, the double that connection, right? Because we said it and we now believe it. Publishing ports, binding addresses at the pod level, not
happens in the pod.
So make sure you understand, you grok that.
We did that just to prove the point.
Of course, absolutely.
It was on purpose. Totally on purpose. Not an accident.
I'm going to go ahead and restart the entire pod.
Oh, did you do your daemon reload? I don't think you did.
I did not. Thank you for that. That is one of the other things with the fact that these are generated.
Yep.
Right. If you make a change, you have to make sure that you reload the daemon so that way that's actual,
true.
Auto generator fires.
That's true for any systemd unit file. If you're changing a unit file, you have to do the reload. Otherwise, it's not going to recognize it.
Correct. But in this case, we have a sort of an extra one because we have to have it create all those extra things for the unit files that we don't.
It's doubly important now. How's that?
Exactly. So we restart the Forgeo.pod, which takes a little while, but silently succeeds or silently doesn't fail. Let's do another Podman PS. And look at that. We now have Codeberg for Geo 10 also running. So now we should have all three of our things running and good to go. We should be able to go ahead and say Podman pod logs for Geo to get our logs for everything. We now see all of the same sorts of things from MySQL. Quick scroll up to the top, and we now get our very mixed in. We have something actually listening on port 3000 on localhost and some other things that we didn't see before about web interfaces for Git servers starting, which is important. So once
try
again,
your curl again then, right?
Well, that grabbed the wrong curl.
Yeah, try it with 127.0.0.1.
I want to try it with localhost. Oh.
Now it's got 3000 and
so that is looking correct.
22.
So here's something I want to try because sometimes curl can be weird. No. Now.
Take off the D.
Pardon?
It's just firewall-cmd, not firewall-d-cmd. There you go.
And we're adding a random port, so we need to name it, and we need to tell it that it's TCP.
What?
All right, so there's an important thing. I don't think I have firewall D even installed on this box.
Well, then that shouldn't be the problem, should it?
Exactly. I don't think we've got a firewall issue here. So let me just go back just in case that it's a curl problem. Does not appear to be a curl problem. So back to the logs.
So what else could it be? Is the Forgeo container didn't start and then die again, did it?
No, it looks like it is still up and running.
Yeah.
All right. So
the container's up, running.
Last time we
are you sure that 3000 is the port within the container we're supposed to direct to? I think it said that in the logs, though, didn't it? So
it did say that it was starting on 3000. So what if I all right, Nate. So what if we try to fire up a container inside the pod to see if we can get to Forgeo from inside the pod, and maybe it's a networking problem. Maybe we're winding up, maybe that blank network definition is actually throwing us off because it's getting a weird set of IP addresses that aren't really relating to what's going on in the outside world. So what do we want to do? I want to go ahead and
you could run like a UBI or a Fedora or a CentOS. As long as you attach it to the pod.
Yep. I think we can do that straight off the bat by just saying pod Forgeo. I don't have anything handy. So what are the odds that the MySQL image has, or the Forgeo image has curl on it? Probably kind of low.
Hold on, I think I've got a container def in my Git repo that I happen to have open on this other tab here that points to UBI. So I could get you the URL for UBI. It's like access.registry or registry.access. I don't remember now, .redhat.com.
The other thing, I just realized there's probably I need to go back to the Forgeo docs because there's a way to test it to see if the SSH port is also open. But I didn't mean to delete all that. Is it rel 9 UBI? Is that right?
Hold on, I'm going to have it just a second. I think, anyway. Here. registry.access.redhat.com/UBI9/UBI is the one I use in my other thing here. So if you want to use 10, go right ahead, but that's up to you.
No, that's perfectly fine. We want to say, give me a shell.
Yay.
Now, this is going to take us a moment while we grab that UBI image. So other things we can, yeah.
No pod with name or ID.
Yeah. Gotta do that because this is a root thing. Okay.
There you go.
So, all right. So now we are inside the pod. We have curl. So curl here, we should be using localhost since all of these things are in a singular namespace that all share what the definition of localhost looks like. This also is having issues.
Oh, good. So I wonder if you shouldn't define a network at all, because the pod has its own internal network. And if you're defining a second network and attaching the containers to it, it makes me wonder if there is something the pod is not expecting in place there.
That is very possible. And this is part of troubleshooting, right? We're going from a definition that is working to a slightly different variation, right? Like the quadlet works with the network defined as it is, but the pod might not because we have a different namespace here. So the pod is
so
going to cause
I'd go back to your container defs and remove the network and then do the daemon reload and restart the pods or restart the services.
So the way we're going to do this is systemd, and really all we need to do is in the Forgeo container itself. Here, we're going to go ahead and we're going to comment out the network for the Forgeo. Is that in the MySQL one as well? And in the MySQL one. Oh, maybe that is actually an interesting problem. We never put it in.
Yeah. I would try it without the network in the Forgeo container anyway, just to see, because that's more native to how the pod should work. Now, I'm not saying you can't use networks within a pod, but I don't know how it reacts. I've never done it.
Right. We could very well be doing something incorrect because we're learning this on the fly. All right, so we reloaded. We've eliminated we commented out the network in the Forgeo container. It was never in the MySQL container, which was an error anyway, right? Like that was a clear error. Like it needed to be one or the other. It needed to be both or not in both. I didn't even put it in there at all. So that was a clear problem. So let's get them both not using the network and restart the pod and see what happens. Because we could have, like that also could have been the problem that I had half of the pod using the network, half the pod not using the network. Who knows what's going on at that point in time?
Yeah, I think what that would have done though is Forgeo still would have been up and running. It just wouldn't have been able to see the database, right?
Correct.
And I think it was up and running, but it was listening on that Forgeo network, and I have no idea how to get to that from the pod.
Right. All right.
So and since the pod is what was listening on port 3000, it wasn't able to get to the service.
Double check our logs. I should really pipe that to less. Everything appears to have started correctly. We once again have all these things working correctly.
Localhost 3000.
Copy that for later. And just to double check, SHTNLP, not BLP. Still looks correct.
22, but it did before. That's the pod. That's the pod listening.
Exactly. But look.
Hey, look at that.
We actually have files. So that means we can go back to
shebang.
And now,
look at that.
We actually have the initial configuration page. we've got all our server domains, we've got all our things, and the only other thing that I think we wind up setting in here somewhere, maybe not, maybe it actually just sort of works. We need to go ahead and set this up. Otherwise actually, you know what, for purposes here, since we're just going to be going ahead, where is self-registration? That's what I wanted to uncheck. Because we're going to blow this away and start it over anyway as we try to now dig in for the next 8 minutes into something else entirely. So I think the one thing there's two things we could do, Nate. I'm going to let you, there's really three things. I'm going to let you pick. So we could get more complicated and try to put a little more production-like volume underneath this and try to create paths and see if we can get Forgeo and MySQL to write to disk. We could go off the rails and see if we can use a Podman secret to pass that username as opposed to hard coding it in the quadlet, which is also something you would want to do in a more production-like environment. Or we can explore an upstream project that was recommended to me that does all of this for us directly from a Docker Compose file and creates all the files automatically. That we don't ship in RHEL yet, but it's kind of a cool upstream project.
As much as I would love to see that, I feel like 7 minutes we have left, maybe tight.
Cool. So it just so happens I've already downloaded this thing called Podlet. So Podlet is an upstream community project. It lives in, and we'll make sure that the link goes out in the show notes. It lives in the container communities GitHub repo in containers/podlet. It is currently not, as far as I know, not releasing in any sort of manner other than tarballs on the GitHub page. I think you can maybe get it through Homebrew if you're on a Mac. But when you unzip that, what you wind up with is a podlet. And this command spews out a whole lot of things, but basically generate a quadlet file from a command from some other object. So that's be something you'd use that Kubernetes pod that you created, or from a compose file. And this is the one that I think folks might want to try it out. So what we have also here is, this is, I downloaded, copy and pasted really, the Docker Compose file from the instructions on the Forgeo website. I have made no other changes whatsoever other than just they presented in sort of diff format. So I did delete a couple of pluses at the start of lines. So let's see here. I'm going to cheat a little bit because I said I didn't do any work, but
cheater.
I sort of did.
Clear your screen. We can't see that command you're typing,
which is fine.
Oh, okay.
So I did a little bit of pre-work. So the thing we want to use is we want to use the compose thing that we saw in that help. And then we want to tell it that we're making a pod, right, by -- pod. And then we tell it the name of the file that we want it to read from. In this case, we're using a compose. So that means we're reading in from a compose object, and the output should be a pod. All right. So first error. Okay. So this is name was error when we're using -pod. So this is a compose.
Give it a name for the pod.
So we need to.
Well, no, it says name is required when using -- pod. So you do -- pod and then a name.
Not exactly. So the error is actually, this is where the error is a little bit confusing because I did that too, and it's actually an error in the compose file. So this compose.
Oh, I get it.
Doesn't have
A name.
A name.
It's nameless, man. We are nameless.
So it's refusing. It's like, hey, I don't know what you want to call this thing, but because we told it take all your input from the compose file, it doesn't know what to do. So now, well, we have a name in that compose file. We run that again, and now we have a complete set of podlet files, just
That's
like
pretty
we
cool.
would have had before.
It makes a pod. It makes
the
did
pod.
make a net. Oh, it didn't put a network, did it?
It did, because there was
made
a
a
network
network.
defined in the Docker compose, right?
So now, knowing what we know, I'd be curious if this even works
exactly
in 3 minutes.
we know it's not going to, because we have the bad volume
Oh, yeah.
locations, right? So I would have
Well,
to make
that could work
Forgeo
if
directories.
you've updated the directories.
Yeah.
In fact, you could update those in the compose file, because those compose files are generally made to be generic, sort of like the Git repo that I shared earlier, where I had a bunch of generic paths in there for things, because I don't know what your paths are going to look like.
Correct. So if we made that path,
Yeah.
this would work. The other thing that was interesting is that it actually creates the dependency.
Yeah, there you go.
Right, that auto. So this is where, if you're running into an issue where you need to start things in order, like you can do with a Docker Compose, or you need to do that with a with the kubeyaml that you're used to. You just throw that in the unit file and say, oh, right, we have the other container that is called DB service. Make sure that this restarts. This starts afterward, right?
Man, do I have a service to try this on?
Yeah, and then all you need to do, right? It just spits this output out. And you just copy these into the appropriately named files it gives you, and it should be good to go.
I got myself onto a tangent a couple weeks ago where, maybe not for all of my domains, but for some domains, I wanted to try to run my own email again, which I haven't done for years, right? So I was looking at this thing called Stalwart, which was pretty cool, but I was running into an issue, and I found this other project called MailCow, which had a much better community support, and it has a containerized deployment. So I'm like, oh, awesome, I'll use this. And I started looking at their container devs, and it's a 600 and something line compose file, ridiculously complex. Now I want to point Podlet at it and see if it chokes.
I mean, this was not a particularly complicated one, so it'd be good to know.
Right.
But yeah, so this is the thing I didn't go deep into was I don't really know, right? Since this is just sort of spitting it out. Here's the name you would use, and then these dividers. Like, you kind of have to copy and paste the output into a file or redirect it, right? You need to break that up yourself in order to get it to dry run. Right?
You would literally copy and paste between those dashes into actual files, and then you'd be fine.
So there's probably a way to get the tool to spit it out, but I didn't go that far. But yeah, it's definitely something to check out if you are looking at
Podlet.
Now that we've got the .pod, right? We successfully created ourselves a .pod. We have a tool that can actually help us like jumpstart a lot of the things we did by hand to kind of get there from an existing compose file. I think in it gives me a little bit of I'm a config first kind of person. The idea of building something to make a config to then tear it down to rebuild it later. It doesn't sit in my brain nearly as well as it might in yours. As I freeze on camera at the end of the
finally freezing
at the end of the stream, making funny faces.
We're done anyway,
which is great. So hopefully, as I fade off into the darkness, so you've learned things today. Thank you once again for joining us. Be sure to like this episode if this is the kind of content that you are looking for. Hit that subscribe, hit that notification so you can join us next time. We're not entirely sure when we're working hard to schedule that one. So until then, when next I see you, on behalf of myself, co-host Nate, special guest as well, and our producer in the booth, Scott, and all of us here on the Red Hat Enterprise Linux team, thank you for joining us today. Hopefully you learned something, and see you next time.
Everybody have a great one.